let me see if this makes sense. Because what you're trying to ask is why the hell does multiplication work that way with fractions, right?
I'm sorry, I haven't done this since 6.
No, it's okay. Now watch. This is kind of cool. This is kind of cool. If you were doing your checkbook, oh my God, and you saw this, couldn't you gather your negatives together? Have you guys done that before, right? So how much positives do I got? 6 and 12, right? So 18. I gather my positive together, and I gather my negatives together. Minus 20, minus 31. Oh shit, I'm in trouble, right? That is... What is that? Negative 13. 31 minus 18, and then you put the negative back on because that's the big one. Alright, now watch. You're all like, what the hell's I got to do with shit? Anything. This is kind of cool. So I got 4 divided by 5 times 2 divided by 7, for example, right? So I'm going to gather all my multiplying stuff. My multiplying stuff is on the top. It's like my positive stuff in a way. And everything I'm dividing by, I'm going to gather all that. So I'm dividing by 5 and by 7. So overall, I'm dividing by... Come on. If I'm dividing by 5 and dividing by 7, overall I'm dividing by... Damn it. All right. If I cut something in half and then cut those in fourths, I just got how many slices? If I cut it in half and then in fourths? 8ths. All right, cool. I thought maybe it could be there. Now, what'd you just do? You did 2 times 4 just to get the total number of slices that you got, right? So if I'm dividing something by 5 and dividing by 7, overall I'm dividing by 35. 5 times 7. So it's the same thing as gathering my negatives together in one place. I'm gathering all the numbers that are dividing in one place. In the place where they are. And what am I multiplying by? What's on the top? 4 times 2, 8. So it's really the same thing as this. All my division numbers come together, so overall I'm dividing by 35. So if I said pick a number and divide it by 2, now divide it by 3. What am I actually dividing by altogether? 6. So if I said divided by 5, now divided by 7, well, I'm dividing by 35 total. That's why you multiply across. I love it. This is what I mean by no question is too small of a question for me. If you don't know why multiplication and fractions work that way they do, I have to come up with a way to explain it to you. I just have to be able to. And I kind of like this. This just came to me a minute ago. We collect the negatives together, we collect the positives. We collect the divisors together, and we collect the multipliers together. 5, 7, 35 total on the bottom, 4, 2, 8 total on the top.
Gotcha. It works.
Right.
I see it.
And plus, what if I had a plus 10? Wouldn't those cancel?
Yeah.
So that's just like if I had a 14 here, the 2's that are common would cancel. It's the same kind of thing. If I have something equal on both sides, they will cancel each other the same way as these would cancel. Because they're opposing forces, right? Okay. Yeah, cool. I like it. Okay, cool. So we did both of those. All right.
I have a question.
Yes.
So, 7, why did the 7 become a 1?
All right,
Sorry,
so...
I know you probably just explained.
That's right. It's if you look at the end result, it gets a little confusing. So let me do this again. Oh, this before. It's on my early purple one. How you doing? All right. Oh yeah, look at that. So what you can do.
I need 7 times. I get. And then into the 23 times.
All right. So if you want to start there, we can.
Oh, okay.
So 7 goes into 35. 5. 7 goes into 21. 3. Okay, is that cool?
Yeah.
So now we're doing it a completely different way than before, which is beautiful. What about here?
2.
5 goes into 10. 2. And of course 5 goes into 5 once.
Oh.
And now 2 goes into 2 once, 2 goes into 8 4 times. So you see, now if you just suddenly came in the room, you would look at that and go, what the freaking hell? But you gotta follow your own work. Did you follow every step?
Just the canceling of the, like it cancels because I don't know. It becomes a 1. It just becomes a 1. No, I don't know.
All right, all right. So again, let me watch this. Let me break this down. Again, this is why, I know I keep saying this, but this is why this works. This is not a way to do this. It is a way to do this, but please don't have to do it this way. 8 is 2 times 2 times 2. Is that cool? 21 is 3 times 7. 35 is 5 times 7. And 10 is 5 times 2. So when I do, what do we do first here? When I do 7 goes into 35 5 times, what I'm doing is I'm saying that 7 and that 7 cancel, and that's why it was a 5 and a 3. And then I kill a 2 this way, and I can kill a 5 that way. But why do I not want you to have to do this? Because the number could have a huge amount. You need to be able to attack them more directly. This is what you're doing in the background, is you're canceling the common factors. Because that would become 1 every time. That's 1, that's 1, that's 1. And then you collect the survivors. So you can do this for a few of the early ones if you're still not completely buying in, but now you should be able to just say, well, that's got a factor of 7, and I'll be left with a 5. If I killed it with a factor of 7, and I'll be left with a 3. Because that's what you're doing here, really. Right? Okay, maybe. Did that, some of you say still look concerned.
It just hurts.
What's up?
I said it just hurts right now. 19 years for me. I had to do some math in my
So those 7s just straight up cancel, right? Here,
Why is that 5 there?
7 goes into 35
Oh,
5 times. 7 goes into 21. So when I say that, what I'm actually doing is killing the 7. If I kill the 7 from this, I'll be left with the 5. If I kill the 7 from this, I'll be left with the 3. Because these 7s kill each other. This is 7 and this is anti-7. Right?
Yes.
Alright, I got you. So let's do another one.
Okay, let's see if I can do this without turning out.
What you got, Jeff? Show me what you got. Oh, get shifted. Good, I like it. Yes, ma'am.
Can we do a 4.3 exercise?
After this, sure.
Original.
I want you guys to understand that this is good. What's happening right now is good. Don't take any... I don't mean to come off as exasperated, because what I'm exasperated about is that you're not asking me questions earlier. You got to ask me questions the minute that something doesn't make sense. So I apologize if I ever come off as like, but to me I'm going back. I'd rather just attack it the minute it comes up. So don't hesitate to ask questions about anything. Even if I do get way past it, still ask me. Give me a second to get over myself, and then we'll do it. The biggest mistake people make on this kind of problem is they get excited about this and they forget that it's still division. What do you have to do first, of course? Yeah. Times.
90.
Okay. So what do you guys see first? I'll let you tell me. What do you see first that works?
40.
All right. Because remember, you could go this way too, but yeah, this will work too. So you go up and down or side to side. So what goes into both of those? Let me do this in different colors. So 5 goes into 15. 5 goes into 40. 8. A lot of people have a problem with 40, but yeah, 5 times 8 is 40. Now, what else do you guys see? I see some beautiful stuff. Looking up and down. Yeah. 8 goes into 64. 8 times. Right. So I divided that by 8 and I get 1. I divided by 64 by 8 and I get 8.
And then 2. 4 and then 4 times.
What about?
That 2. Whatever way you want to do
Yeah.
it.
Oh,
3 goes into 90.
3 times, 30 times.
30 times. And then finally,
All of a sudden.
now watch, if you don't like, if you're like, okay, shit, let me just stop for a second. You can collect yourself right now. 1 times 30 is 30.
30 over 8.
8 times 1 is, go away, Blue, sorry buddy. You've had too much. 30 over 8, and then you can see, okay, I've collected all my survivors before it gets too crazy and I can't tell what's going on. Now just keep going. Yeah, what goes into both?
8, 30.
8 does not go into both?
On the bowl, my bad. 3, 8, 15 over 4.
Yeah, divide by 2. 15 over 4, I like it. All right. Is that cool? Because the big problem with this is you kind of lose what's still alive. You can do one thing and then write what's left and then keep attacking that thing. Yes?
And that's just the final answer.
Yeah, and just in case, what is it as a mixed number? Just in case they want that.
4 divided by
Yeah, 4 goes into 15. 3 times with
4.
3 left over. Okay, I like it.
I feel like I'm gonna start sweating.
I have to go give like half my blood after this.
But do you guys understand better now or no? Do you understand better now? So that's what you focus on. You don't focus on, man, that was some shit. You focus on, well, now I feel better about that. Right, after I go to the gym, I don't focus on how hard that was and how much I hurt myself trying to lift the same way. After, I'm like, oh, it's over. I feel good. Okay. I feel so good right now. Okay.
My bad.
All right, guys. So one last thing before we head out. We focus so much on multiplying and dividing. I just want to do a little bit of getting into adding and subtracting. So I'm almost certain well, let's see. Help me out. What's 7x minus 4x? 3x. Do you see how that's the same question? Some of you guys are like, all right, dude, no, there's some 9s in there, fraction. 7 of these minus 4 of these is 3 of these. So 3 9ths. And of course, the last thing you always check is if that fraction can reduce. Yeah, 1/3. That's right, 1/3. I like it, I like it. So that was easy because the bottoms were already the same.
So really you just go across unless it's freaking division, correct?
Basically, yes.
So that's the only one that you have to like...
Well, you do one thing. You don't edit, you do one thing and then it's the same as always.
That's not one thing, that's a
No.
lot of things.
No. After that, it was a multiplication problem. One step and it's no longer a division problem. Do you see what I'm saying?
Yeah.
Division is one step away from multiplication, and if you understand multiplication, therefore you understand division.
But everything else you just literally just...
Yes, totally. And why is it... I didn't do this the other day with you guys. What's 7 chairs minus 4 chairs? 3 chairs. So it's 7 pineapples minus 3 pineapples. I tricked you. 4 pineapples, right? What's 7 shoes minus 4 shoes? 3 shoes. So what's 7 9ths minus 4 9ths? 3 9ths. I mean, there's nothing more than that's. I'm collecting how many 9ths I've got.
Yeah.
Do you guys see that?
Good
The bottom
question.
is different.
Beautiful.
The new jet.
Beautiful.
Denominator.
The reason we can do something about that. So if I had, let's say, 7/9 minus 1/3. That is like 7x minus 1y. Can I do anything with that? It's not like terms. But this I can't do anything with because they're freaking letters. These are numbers. There's hope. I can do stuff with numbers. I can't do stuff with y and x. So 1/3, I can build it up. 1/3 was reduced from what ninths? How do I make this into something ninths? What do I do to the bottom to make it become 9? Multiply by 3. So I better do the same thing to the top to make it legal.
I was correct. I actually remembered something. I'm not retarded.
Yeah. Okay, we haven't finished that, right?
Use a bigger number.
We haven't finished that. Hold on. Let's actually finish that problem. Yes.
They hurt.
So then multiply by 3. Multiply by 3. Why am I allowed to do that? Because what is 3 over 3?
What?
And I can multiply anything I want to by 1.
Yep.
So that means I can multiply anything I want to by 7 over 7. I can multiply anything I want to by 1011.7 divided by 1011.7 if I wanted to. I don't always want to do that. Here, I want to multiply by 3 over 3, which is completely legal because it's 1, because that makes the bottom become the same, 9. So I get 7/9 minus. Oh, 4 9s, okay. Subtraction, yeah. Okay, now.
Do a bigger one?
Sure. And then I think I'll give you this handout. I got a really cool method, and I'm probably the only person in the world that would call it cool.
Is it the Jeff method?
Sure, man. No, it's not. It's a well-known method, but not every book shows you this, but I think this book actually does.
That freaks me out.
Let me start off nice. This is one where you don't need my amazing method. Let's see if you guys can see this. Sure. Alright. Well, that's too easy, sir. That'll work. Now, the most direct way to do this, you gotta find the LCD, you gotta find a way to make the bottoms the same. I can't just multiply by 4 and make it become 18 like I did over there. Because 3 goes into 9, but 4 does not go nicely into 18. But what I can do is, if I take 18 and start counting by 18s, what's 18 plus 18?
36.
Now, does 4 go into 36? So I can multiply both fractions by something so that they meet somewhere.
Make them bigger.
Yes. So I'll multiply this by 2, and multiply this by, to make it 36, 9.
Now what happened?
Well, what's 11 times 2?
22, 36,
I'm just going to keep being your straight man.
45.
Yep, 45. And now you're allowed to add them because now they're both some number of 36ths. So what do you get? 22 plus 45?
67. 36.
It should be 1 and 31 36, but you know.
Yeah. Who's counting?
So now let's do a worse one, and then I'll give you this handout that we'll work on next time. We'll do one more.
He's multiplying 9 times 4.
What's happening? Sorry. What happened?
Sorry.
What's up?
Where you get the 2 from? I'm just wondering where
What
the
number
9
can I multiply 18 to become that I can also multiply 4 to become? Well, 18 becomes 36.
Which one was it?
I can just start counting by 18s. And 4 becomes 36. So that's where they can both meet. Why was that one easier? Because 3 can become 9, and that is 9. So, yay, I only had to change one fraction here. I got to change them both so they both meet somewhere.
Gotcha.
Kick ass. So here, what about if it wasn't as nice as that? Because that is actually nice.
Yeah.
So what about this one? Let's see. What about
is all.
Oh shit. 11/18 minus 7 over 54. Yeah, I like that. It's gross.
Holy shit. You guys are
I was
All right, now watch. Now watch. I want to show you this because this kicks so much ass. Can you tell me what the biggest number is that goes into both of those?
6.
No. Bigger.
9.
9. All right, let me stop there for a second. Is everybody with me on that? D, can you come towards me a little bit? A little bit over that way. Oh no. Are you able to? All right. All right, I can just go over there. You're good, man. Stay right there. This is old, right? All right, now what do we say? They both have a 9 in there, right? So you have to be able to do that to use this method. What's the biggest number that goes into both? 9. So 18 is 9 times 2. 54 is 9 times 6. So that's actually a bigger number that goes into both, but oh well, too bad for me. I'll just go with this, just to show you this method. Now watch. Hopefully nobody knows. Comparing these, what is this guy missing that this guy has?
6.
No, he's got a 6.
I mean, 2.
Be careful the way I say it. Do you understand what I'm saying? This is the idea of LCD. Do you see how this was missing a 2 and this was missing a 9 to become the same number? Well, if I break them down like this, I can see what are they both missing because I can see what they both have. This guy's missing a 2. This guy's missing a 6. What happened? Now they both, what do they both have on the bottom now? This number. Don't they both have that same number?
Yeah.
So I've made the bottoms the same by multiplying by what they were missing. That kicks so much ass. So if the bottoms are disgusting, huge or gross, break them all the way down, and then you can see who's missing what. So now I get 66 minus 14 over, what's 6 times 9 times 2?
108.
108? Okay. 52 over 108, which I can reduce. Just keep doing 26 divided by 54, 13 over 27. I think that's right. I just keep dividing by 2 because they were even. If you don't see something and they're even, just do 2. Make them smaller. So let me give you this. One side is talking about just kind of like changing a mixed number, changing improper fraction, reducing fractions to lowest terms, multiplying fractions. And the other side is what we got into just now. So we're going to do this side next time, adding fractions with unlike denominators. I'll put that in here for you.
Yeah, I'm thinking. I was thinking of basketball.
Oh yeah.
Why don't you go and look?
I do. It's not today.
What up?